Hello, everyone, and welcome back to my channel. Last week, we have talked about multiplication and division of integers. That is a basic operation of integer. If you haven't watched that video, please click the suggested video above. And before that, we have also talked about addition of integers. That is very important. Before you watch this video, you have to watch that first. So please click the suggested video above. And of course, we have also talked about subtraction of teachers, which is normally hard for some of the students. That's fine. I have gave some hints, tips, tricks, techniques in that video. So if you haven't watched that, please click the suggested video above. For this video, we are going to talk about Mathematics 7, Quarter 1, Module 4. That is about properties of operations on the set of integers. Throughout the discussion, assume that the numbers represented by the letters A and B are integers. A and B are variables. Variables are letters that represent integers. Now, let us start our discussion on the different properties. But before we start our discussion, I have come up to a table that will make it easier for you to remember, of course, the keyword. And then I have also tested if these properties are applicable in addition, subtraction, multiplication, and division. The first property is the closure property. Two integers that are added and multiplied remain as integers. The set of integers is closed under addition and multiplication. The closure property of addition for real numbers states that if A and B are real numbers, then A plus B is a unique real number. Example: adding two real numbers produces another real number. 15 plus 16 is equal to 31. The number 31 is a real number. Therefore, the closure property is applicable in addition. The closure property of multiplication for real numbers states that if A and B are real numbers, then A multiplied to B is a unique real number. Example: multiplying two real numbers produces another real number. 26 multiplied by 12 is equal to 312. Therefore, the number 312 is a real number. The closure property is also applicable in multiplication. Now let's test the closure property in subtraction and division. Let's prove that the closure property is applicable also in subtraction. 8 minus 3 is equal to 5. 31 minus 15 is equal to 16. 14 minus 1 is equal to 13. Division: 4 divided by 3 is equal to 1 and 33/100ths. 8 divided by 6 is equal to 75/100ths. 10 divided by 2 is equal to 4 and 5/10ths. Now the closure property is not applicable in division. To sum it up, the closure property is a real number and a real number that gives us an answer that is also a real number. Therefore, the keyword for closure property is unique real number. The given terms are normally two, only two terms, but sometimes it is more than two. It can be 3 terms, 4 terms, and so on. And to sum it up, it is applicable in addition, subtraction, multiplication, but not in division. Our second property is commutative property. Changing the order of two numbers that are either being added or multiplied does not change the value. A plus B is equal to B plus A. AB is equal to BA. Remember, if variables doesn't have an operation in between, the operation is automatically multiplication. Example: 2 plus 3 is equal to 3 plus 2, since 2 plus 3 is equal to 5, and also 3 plus 2 is equal to 5. Negative 16 plus negative 5 is equal to negative 5 plus negative 16. That gives us negative 21. 100 plus 99 is equal to 99 plus 100. That gives us 199. 2 multiplied by 3 is equal to 3 multiplied by 2. Since 2 times 3 is equal to 6, and also 3 times 2 is equal to 6. Negative 4 multiplied by negative 15 is equal to negative 15 multiplied by negative 4, which gives us 60. Now we have proven that the commutative property is applicable in addition and multiplication. 10 multiplied by 25 is equal to 25 multiplied by 10, which gives us 250. Now we have proven that the commutative property is applicable in both addition and multiplication. Now let's try proving it in subtraction. Let's see if this is applicable. Let's say 6 minus 3 is equal to 3 minus 6. It is not, because 6 minus 3 gives us 3, and 3 minus 6 gives us negative 3. Another example, 4 minus 5 is equal to 5 minus 4. 4 minus 5 gives us negative 1, and 5 minus 4 gives us 1, which are not equal. 7 minus 2 is equal to 2 minus 7. 7 minus 2 gives us 5, and 2 minus 7 gives us negative 5. Therefore, the commutative property is not applicable in subtraction. Now let's try in division. 6 divided by 3 is equal to 3 divided by 6. 6 divided by 3 gives us 2, and 3 divided by 6 gives us 5/10. Now that is not equal. 4 divided by 5 is equal to 5 divided by 4. 4 divided by 5 gives us 8/10, and 5 divided by 4 gives us 1 and 25/100, and that is not equal. 7 divided by 2 is equal to 2 divided by 7. 7 divided by 2 gives us 3 and 5/10, and 2 divided by 7 gives us 29/100. And that is also not equal. Therefore, the commutative property is not applicable in division. Let's sum it up. Again, the closure property is a unique real number applicable in addition, subtraction, and multiplication. For our commutative property, our keyword is order. It will give us the same answer no matter what order the terms are. For the given terms, it can be 2 terms or more, can be 3 terms, and so on. And it is also applicable in addition. In subtraction, it is not applicable. In multiplication, it is also applicable. In division, it is not applicable. The third property is associative property. Changing the grouping of numbers that are either being added or multiplied does not change its value. Quantity of A plus B plus C is equal to A plus the quantity of B plus C, or the quantity of A and B multiplied to C is equal to A multiplied to the quantity of B and C. Example, the quantity of 2 plus 3 added to 4 is equal to 2 plus the quantity of 3 plus 4. Let's check. These are the given terms. 2 plus 3 is equal to 5 plus 4, which should be equal to 2 plus 7, because 3 plus 4 is equal to 7. Now 9 is equal to 9. Another example, the quantity of 10 plus 5 added to 8 is equal to 10 plus the quantity of 5 plus 8. Now you have noticed that in the example, we have changed the grouping of numbers, that is the associative property. Now let's check. First, we add 10 and 5, that is on the left side of our equation, and on the right side of our equation, we add 5 and 8 first. Now 15 plus 8 is equal to 10 plus 13. 15 and 8 gives us 23, and 10 and 13 gives us also 23. Therefore, the associative property is applicable in addition. Let's try in multiplication. We multiply 4 and 3 first, and then we multiply the product by 5. And on the right side of the equation, we multiply 3 and 5 first before we multiply it by 4. In this rule, we are following the PEMDAS rule. If you have heard about that, that is, you multiply first or you operate first the quantities that are in the parentheses and exponent, then second multiplication and division before you proceed to addition and subtraction. That is applied in the associative property. Now multiplying 4 and 3 gives us 12 multiplied by 5. And then multiplying 3 and 5 gives us 15 multiplied by 4. Now 12 and 5 gives us 60. And 14 and 15 also gives us 60. Another example. First, we multiply 2 and 10 before we multiply the product by 4. And then we multiply 10 and 4 before we multiply the product by 2. Now 2 and 10 gives us 20 multiplied to 4. That is equal to 40 multiplied by 2. Now 20 multiplied by 4 gives us 80. And 2 multiplied by 40 gives us also 80. Now the associative property is also applicable in multiplication. Let's try if it is applicable in subtraction. The quantity of 6 less 3 less 1. Of course, we subtract first 6 and 3. And then on the right side of the equation, that is 6 less the quantity of 3 minus 1. So on the right side of the equation, we subtract 3 minus 1 first. Now, 6 minus 3 is equal to 3 minus 1. And then 6 minus 2. Now the answer on the left side of the equation is 2, and on the right side of the equation is 4. It is not equal. Another example. 15 minus 9. We operate this first, that is equal to 6. And then we subtract 5 from 6. On the right side of the equation, we subtract 9 minus 5 first, and we subtract the difference from 15. Now 6 minus 5 is equal to 1, and 15 minus 4 is equal to 11. 1 and 11 are not equal. And for our last example, 12 less 5. This is the first thing that we have to subtract. That gives us 7 less 4. On the right side, we subtract 5 minus 4, that is equal to 1. That gives us 12 minus 1. 7 minus 4 is equal to 3, and 12 minus 1 is equal to 11. Therefore, the associative property is not applicable in subtraction. Let's try it in division. 9 divided by 3 first, that gives us 3 divided by 3. And then the right side of the equation, we divide 3 divided by 3 first, and we divide the quotient by 9. That gives us 9 divided by 1. 3 divided by 3 is equal to 1, and 9 divided by 1 is equal to 9. And they are not equal. Another example, 24 divided by 8 is equal to 3 divided by 2, which should be equal to 24 divided by 4. 3 divided by 2 is equal to 1.5, and 24 divided by 4 is equal to 6. And they are not equal. And for our last example, 50 divided by 5 is equal to 10. And then we divide it by 4. That should be equal with 50 divided by 1 and 25 hundredths. Now the answer on the left side of the equation is 2 and 5 tenths, and the right side of the equation is 40. And they are not equal, therefore the associative property is not applicable in division. Let's go back to our table. Again, the keyword for closure property is real number that is applicable in addition, subtraction, and multiplication. For commutative property, the keyword is order that is applicable in addition, multiplication only. Now for the associative property, our keyword is grouping. the given terms is equal to 3 or more than 3, we can have 4 terms, 5 terms, and so on. And also, as a tip for you, in the associative property, you can always find a parenthesis. It is applicable in addition, not in subtraction. Yes, it is applicable in multiplication, but not in division.
Please click the subscribe button and bell button for notifications. Thank you.
Our fourth property is the distributive property. When two numbers have been added or subtracted and then multiplied by a factor, the result will be the same when each number is multiplied by the factor and the products are then added or subtracted. Now in the distributive property, it is always distributive property of multiplication on another operation. So this means that we will have two operations in this property. That's a tip. We should apply multiplication and addition, or multiplication and subtraction, or multiplication and division, or multiplication and multiplication. Let's see if in which operations is this applicable. A multiplied to the quantity of B plus C should be equal to AB plus AC. Or A multiplied to the quantity of B minus C is equal to AB minus AC. Let's apply it for you to better understand it. 2 multiplied to the quantity of 3 plus 4 is equal to, now we distribute 2 multiplied by 3 plus, because the sign inside the parenthesis is addition, and then we multiply 2 and 4. That is distributive property. We distribute 2 in 3 and then 4. On the left side of the equation, first we add the terms in the parenthesis, 3 and 4, that is equal to 7, before we multiply it by 2. On the right side of the equation, we multiply 2 and 3, that gives us 6, and we add it to the product of 2 and 4, that is 8. The answer are both 14. Another example. 5 multiplied to the quantity of 8 less 3. Now we distribute 5 multiplied by 8 less 5 multiplied by 3, since the operation in the parenthesis is subtraction. To check, of course, on the left side of the equation, we subtract 8 minus 3 first before we multiply it by 5. That is 5 multiplied by 5. And on the right side of the equation, 5 multiplied by 8 is equal to 40 less 5 multiplied by 3, that is equal to 15. That gives us the same answer, that is 25. Now the distributive property is applicable in addition and subtraction. Now let's try if it is applicable in multiplication. Let's have an example. 2 multiplied to the quantity of 6 and 3. We distribute 2 multiplied to 6 and then 2 multiplied by 3. Now the operation should be multiplication because that is the operation in the parenthesis. On the left side of the equation, we operate 6 multiplied by 3 is equal to 18 multiplied by 2. Now, on the right side of the equation, 2 multiplied by 6 is equal to 12. And 2 multiplied by 3 is equal to 6. 12 and 6 gives us 72. And 2 multiplied by 18 gives us 36. Now that is not equal. For another example, here we distribute 3 to 4 and 5. Now that gives us 3 multiplied by 4 times 3 multiplied by 5. On the left side of the equation, of course, we multiply 4 and 5 first. That gives us 20 before we multiply it by 3. On the right side of the equation, we multiply 3 and 4. That gives us 12. And then we multiply it by 15. That gives us the final answer of 60, which should be equal to 180. And it is not equal. And in our last example, That is, we are trying to prove if the distributive property is not applicable in multiplication. Our final answer is 24 and 96. That does not apply in multiplication. Now for our conclusion, the distributive property is not applicable in multiplication. Now let's try in division. We have our examples here. 2 multiplied to the quantity of 6 divided by 3 should be equal to 2 multiplied by 6 divided by 2 multiplied by 3. Now on the left side of the equation, we have to divide 6 and 3 first because that is inside the parenthesis. That gives us 2 multiplied by 2. And the right side of the equation, that gives us 12 divided by 6. The final answer is 4 should be equal to 2, and that is not equal. Another example, 3 multiplied to the quantity of 4 divided by 5 should be equal to, if 3 is distributed in 4 and 5. Now that gives us a final answer of 2 and 4 tenths, which is not equal with 8 tenths. For our last example, we tried to distribute 4 to 3 and 2, and it also gave us the answers that are not equal. Therefore, the distributive property is not applicable in division. Now going back to our table, the distributive property of multiplication over an operation, the keyword here is distribution because we distribute the term outside the parenthesis and the given terms might be 3 or more. Now for a tip, it also has a parenthesis. There is a common term and we use two processes. Yes in addition, yes in subtraction, not in multiplication and division. For our fifth property, that is the identity property. The additive identity states that the sum of any number and 0 is the given number. 0 is the additive identity. A plus 0 is equal to A. Example, 4 plus 0 is equal to 4. Negative 10 plus 0 is negative 10. 99 plus 0 is 99. Now you can notice that in all our examples, we have added 0 because 0 is the identity property of addition. Now the sum did not change. In multiplication, the identity property is 1 because any number multiplied by 1 is the number itself. Example, 12 multiplied by 1 is equal to 12. Negative 32 multiplied by 1 is equal to negative 32. 99 multiplied by 1 is equal to 99. Now the multiplicative identity of multiplication is 1. Let's try in subtraction. We all know that if we subtract 0 from any number, the difference is the number. So the identity property of subtraction is 0. For division, dividing any number by 1 gives us the number. Now the identity property of division is 1. Going back to our table, the identity property, our keyword is the same value or the value did not change. The given is a term and 0 or 1. Now we can easily identify if we are applying identity property in an equation because we can normally see the 0 if the operation is addition or subtraction and 1 if the operation is multiplication or division. Now for addition, identity property is 0. For subtraction, it's 0 also. And for multiplication and division is 1. Now for our last property is the inverse property. Inverse property is more of the identity property but the other way around. You'll see. The additive inverse states that the sum of any number and its additive inverse is 0. The additive inverse of a positive number is a negative of that number. That is A plus negative A is equal to 0. And the additive inverse of a negative number is the positive of that number. That is negative A plus A is equal to 0. Now let's put it in an example. The inverse of 9 is negative 9. Now 9 plus negative 9 is equal to 0. Negative 58 plus 58 is equal to 0. 99 plus negative 99 is equal to 0. Remember, in the inverse property, the answer is always the identity property. The multiplicative inverse property states that the product of any number and its multiplicative inverse or reciprocal is 1. The multiplicative inverse of a number a is 1 over a. A multiplied to 1 over a is equal to 1. Example, the inverse of 6 is 1/6. Multiplicative inverse, because the denominator of a whole number is 1. Now the reciprocal of 6 over 1 is equal to 1/6. That gives us 1. Negative 22 multiplied to negative 1 over 22 is equal to 1. 4/7 multiplied to its reciprocal, that is 7/4, is equal to 28 over 28, that is equal to 1. 5/8 multiplied to 8 over 5 is equal to 40 over 40, that is also equal to 1. Now you can notice that in the inverse property of multiplication, the answer is the identity property of multiplication. I have tried to figure out if in subtraction it is also applicable, but it is not, based on the 3 examples that I have tested. And also in division, I have tried to test 3 examples if the inverse property applies in division, and it came up to be not applicable. Now going back to our table, the inverse property with the keyword of opposite, the given terms is 2. The answer is identity property. That is applicable in addition, but not in subtraction. A yes in multiplication, but not in division. Now that we have talked about all the properties, let us try to review what you have remembered. 1 plus 4 is equal to 5. What property is that? That is the closure property of addition. Another, 4 plus 0 is equal to 4. Now remember, we have 0, that is the identity property. And what is the process? Addition. Therefore, identity property of addition. Another one, negative 5 plus 5 is equal to 0. Now if you have noticed, 5 is the inverse of negative 5. That is additive inverse. Therefore, inverse property of addition. 2 multiplied to negative 3 is equal to negative 3 multiplied by 2. If you have noticed, the order has changed. For order, keyword, that is the commutative property of multiplication. 3 minus 0 is equal to 3. Now 0 is the identity property of addition and subtraction, and the operation here is subtraction. Therefore, it is the identity property of subtraction. 4 plus the quantity of 1 plus 3 is equal to the quantity of 4 plus 1 added to 3. Now you have noticed that we have changed the grouping of numbers, and if it is grouping and the operation is addition, that is associative property of addition. Another one, 4 multiplied to the quantity of 2 less 7, and we distributed 4 multiplied by 2 less 4 multiplied by 7. Distribute, that is distributive property of multiplication over subtraction, because subtraction is the process in the parentheses. 5 multiplied to the quantity of x plus 3. Now we distributed 5 multiplied by x, that is 5x, and 5 multiplied by 3, that is equal to 15, and then we added the terms because the process is addition. Again, we distributed, that is distributive property of multiplication over addition. A multiplied to the quantity of 3 plus 4 is equal to 3A plus 4A. Again, we have distributed A, that is distributive property of multiplication over addition. What we have here, that is negative x plus x. Now, negative x is the additive inverse of x, therefore, inverse property of addition. Another one, we have 4 multiplied to the quantity of 5 and 3 is equal to 4 multiplied by 5 times 4 multiplied by 3. Now we distributed 4, therefore that is distributive property of multiplication over multiplication, but it does not exist. Another one, 2 multiplied to the quantity of 3 times 7 is equal to the quantity of 2 times 3 multiplied by 7. Now we have changed the grouping. Grouping is associative. The process is multiplication. Associative property of multiplication. 5 plus the quantity of 3 plus 8 is equal to 5 plus 3. Then we add 8. We have changed again to grouping. The process, addition. Grouping is associative property of addition. Another example, we have 3/4 multiplied by 4/3. Now, what have we noticed here? 4/3 is the reciprocal of 3/4. And the reciprocal is applicable in multiplicative inverse. Now, this is inverse property of multiplication. And you have noticed the product is the identity property of multiplication. That is 1. Another example, a negative 9 multiplied by 1 is negative 9. Now, as what I have said, if you can find 1 or 0, that can probably be the identity property of multiplication. And for our last example, we have negative x plus negative 1 is equal to negative 1 plus negative x. We have changed the order. If we are talking about change of order, that is commutative property and the operation is addition. Now let's say commutative property of addition. And that's the end of our lesson today. I hope that you have learned a lot, and if you have questions or recommendations or any topic that you want me to discuss, I'm open all the time. You can write it in the comment section. In my next video, I am going to talk about changing fractions to decimals and decimals to fractions. So stay tuned and thank you for watching.